Okay, we're gonna look at, let me see what's there. Fun, 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 fun. Most fun concept here. Okay, this is from the Limpopo, there, uptown there. You know, see what they were writing in 2019. So remember that like caps is just a repeat, you know, and nothing's gonna change. Just gonna ask you this year how many apples were green. The next year they'll ask you how many. No, no, they won't say how many. If if four apples are green, and I don't like, yeah, you know what I'm trying to do? I'm trying to like correlate stuff. You know how they blend. Okay, I'm speaking nonsense. It's nonsense. Nonsense. Getting to the first question is question 5 of extraction. Remember, the functions contribute 35%. No, no, 30% of paper Y. So 30%, that's a lot. That's like 45 marks. That's a lot. So if you know functions as a topic, you know, it'll be easy for you to accumulate marks there. So in this question, you are given a hyperbola, right? So you have um the value of a, right? In the diagram below, f of x is defined by k over x minus p plus q, where a is 2 and 1. This is a point of intersection of the asymptotes. Okay, this is a very crucial point. You have another point, which is the y-intercept. Okay, so you're given asymptotes and y-intercepts for the hyperbola. The first question is to write down the equations for the asymptotes. What I know from the asymptotes, I know that y, the horizontal asymptote, the horizontal asymptote is defined by y. So y is going to be equal to q, right? And the horizontal asymptote here, it's this one. So y is equal to 1. Then I look at uh, the vertical asymptote. Vertical asymptote, do you remember from the equation? You have this, then you equate it to 0. So it's going to be a different sign, right? A different sign when you put it into the equation. But as an asymptote, it's going to be x is equal to 2. It's just that 2. And then, yeah, this is what I'm saying. They're asking that in the second equation, where they're saying determine the value of f. Right, so the value of, the equation of f is going to be f at x is equal to k over x. I know p, I know that p is what we call the asymptote. So it's gonna be a different sign than plus 1. I just take 1 as it is from here. It's the asymptote. And then to solve for k, I'm gonna substitute using this coordinate here, b. So the y value is -2. Then this is equal to k over 0 minus 2 plus 1. Therefore, the value of k, when I solve this, is going to be -3. When I take the on that side, it's a -3, then over -2. So I have a +6. That is my value of k. So therefore, the equation of f is defined by 6 over x minus 2 plus 1. Let's get to the third question. The domain. The domain of the parabola, the hyperbola is easy. X element of real numbers. The domain, they're asking you about the x values. So the graph exists for all these values in the function, except the asymptote. Except, what is the asymptote? Here is your asymptote. Accept the asymptote. Same thing if they asked about the range, right? Same thing if they asked about the range. You need to know this thing. Same thing if they ask you about for y is equal to a over x minus p plus q hyperbola, right? The range and then domain, right? The range is all the values of x for which the graph exists. So it means all those values where the graph exists, where you can sketch the graph. So for the range of this, y is exist everywhere except at the asymptote. The domain, it exists everywhere except the asymptote. Not p, but the asymptote. Remember, if you have example, y is equal to 2 over x plus 4 minus 3. The range, y is going to be, it's not going to be equal to negative 3. That's the range from this. And then the domain, x is not going to be equal to what? A negative 4, right? Pay careful attention there to the signs, right? Because here's a positive, then that is the asymptote. There's a different sign for p. Okay. Let's get to the question. So the last question, coordinates of D. D is the y-intercept, it's the x-intercept. So I know x-intercept, the value of y is 0. So I have 0 being equal to, from this equation here, 6 over x minus 2 plus 1. Then I have negative 1 equals 6 over x minus 2. This is general algebra. So I can conclude that the value of x, when I multiply everything here, I have negative x plus 2 plus 6. So it's going to be positive 4. Right, so not a positive 4, a negative 4. Negative 4. Yes. I have negative 4. And then it means that the coordinates of D is negative 4 is to 0. Going to the next question. Let's get to you have D here. So the coordinates for D is going to be negative 4 is to 0. It's the coordinates for D. Okay, gets into the next question. All right, so calculate the equation of the function. Okay, we have a new function, parabola, which goes through B, C, and D. Where are C and D are the x? What? Wait. Yay. What? Which calculate the equation of the function h at x, which goes through the point B, C, and D, where are by doubles. By doubles. I've said like what doubles and by doubles. But it's fine. Anyway, we are not there. We don't care about others. We're here for the maths. So check. So F, C, and D are x-intercepts. C, D, x-intercept. And also it passes through this point. And it's a parabola. Definitely. Parabola is shaped like this. I know for sure. This is what I'm gonna have. This is what I'm gonna have. So they want the I don't know like what happened. just did the thing. Like it like automatically did that, like, and I'm not lying. Okay, but anyway, we're not there. It's fine. This is h of x. It calculated it so. Okay, so the equation. There are ways to determine the equation of a parabola. I'm going to show you. Given a parabola, right? Or you can say quadratic. I don't know what's going on now. You can say the quadratic. You're going to go to the whiteboard. Yeah. Right. So if you are given intercepts, inter intercepts and point, use this equation. Y is equal to a x minus x1, x minus x2. I think I explained this in the previous clip where I said this thing here, these represent intercepts, x intercepts. And then these ones here, this is the same point with this, right? They come from a point, x then y. So intercepts and a point, you use this thing, right? So you're gonna substitute here, then you solve the value of a, then you get the whole equation. And then if you are given, what's this? Given turning point and any point, right? You use this thing, y is equals to a x minus p all squared plus q. These here, these, this is the turning point as it's minus p and q, right? That's a turning point, a different sign. So for example, if turning point is 5, then -3, y is equals to a, then x minus 5 all squared minus 3. So always pay careful attention to the signs. You see how you substitute. You see here is positive, there is negative. So it's always different signs with the turning point. Good. So we're getting here. When we get here, y and x is what? It's any point, right? It can be a point, x and y, right? So the different ways, when you're given the y-intercept, I feel like when you're given the y-intercept and a point, that's when you can use y is equals to a x squared plus bx plus c, because this is the y-intercept. Then you can use simultaneous to find a and b. Good, or you can be given a value of a. This is for determining, I don't know why this thing is slim. This is for determining the equation. So in exams, they give you either intercept and a point, turning point and any point, or they'll give you, this is rare, where you're given the y-intercept and probably a or b. Then you'll use it with a question. Most of the time they ask about these two, intercept and a point, and then turning point and any point. Okay, let's get back to this thing here. Okay, so I'm given intercept and a point. So y is equal to a, then x minus intercept. Good. So be careful when I'm gonna substitute here. I'll start with B. Using B, right? B is 0 and negative 2. So I'm going to substitute. In the place of y, I'm putting negative 2 equal to a, then that's a point. The y-intercept. So I have 0, right? I have 0, then minus x1, then I have the same point again, 0, then minus intercept. Then now I get to the intercept, which is D. It's what, negative? I don't know why is it negative 8 there? Because the answer is negative, it's not negative 8 here, it's negative 4. It's to 0. This is from here. There's the answer. We've calculated it here. So I have negative 4 is to 0. Then I have C, which is 2 is to 0. How did I get to? C is passing through, the asymptote cuts through C, right? And it's 2. So the value of y here at the x-axis is 0. So I'm going to have my values now. I have negative 2 equal to a. Then I have 0 minus negative 4. Right? Then I have 0 minus, and how you have minus 2. Minus 2. So this thing's gonna give you negative 2. Then you have positive 4, negative 8a. So if I divide by negative 8, negative 8, so I'm gonna have a being equal to a quarter. And then go into the equation. Let's get here. Y is going to be equal to a quarter, then x minus, going back to the intercepts, minus 4, and then x minus 2. So we have a quarter into x plus 4, x minus 2. This is just general algebra here. So you know it's going to have x squared plus 2x minus 8. Then a quarter x squared plus 1 over 2x minus 2. That's your final answer. That's the h of x. Now, getting to the last question. You are given the exponential here. Exponential. This one is easy. To sketch an exponential auto, you just need the shape. And then you need the asymptotes. Then you need what? Intercepts. 3 elements to sketch. That's what you need. So we'll start with the shape. Let's get back to the exponential shapes. I'm repeating this. In the previous thing, we did this. I remember. So expo. So under the expo, we have where b is greater than, no, before b. Let me say y equals a b exponent x plus p plus q. Shape is determined by a and b. If a is greater than 0. I told you the function is above the asymptote. So either you're going to have something like this or something like this if A is positive. The minute B becomes a fraction, then that's the shape you have. But if B now is greater than 1, this is the shape you have. Good. So if A is less than 0, you have two shapes. This one and this one here. Right, so if B is a fraction, B is a fraction, that's what you have. If B is greater than 1, this is what you have. Good. So in the question that we have, we're going to look at the given equation. You are given B greater than 1 and A greater than 0 is positive. So this is the shape that I have. I've written all the shape. Then I come to the asymptote. The asymptote is given by, here is the asymptote. Asymptote. We only have one asymptote. We only have one asymptote, which is this one. It is the horizontal asymptote. So if I have y is equals to 3x plus 4, my asymptote is 4. But if I have y is equal to 2 exponent x, I don't have anything. It means that there's something invisible there. Something invisible to 0. So therefore, my horizontal asymptote, y is going to be 0. Getting back to this question, I have the asymptote now. Y is equal to 0. That is my asymptote. Y is equal to 0. Then followed by the intercept. I cannot have the x-intercept because of x, remember x-intercept, y is 0. If this is the asymptote, it means my graph is not going to touch this line here. I'm not going to have a point crossing this line of the x-axis. So I can calculate the x-intercept. X-intercept y equals 0. So I have 2 exponent y is equals to 2 exponent 0 plus 2. Right, I'm substituting 0 here at x. So this is going to give me 4. I have a y-intercept of 4. This. Let me fix this quickly. Y-intercept is x equals 0. And then my graph is going to be in this shape. That's where I took the shape. I know the asymptote, calculated the x-intercept. Another 3 marks, the last one. Given g at x minus 3, bro. This is so simple. You substitute here in the equation, because you have the equation, you just put x minus 3 inside here. That's what I did. Where I see x, I put that thing inside. This is x minus 3 plus 2. This is 1. Therefore, g at x minus 3 is equal to 2x minus 1. 3 marks. That was an easy question.